And welcome everybody to the Daily Space Weather. Before we get started with today's content, a little bit about yesterday. Yesterday I completely dropped the ball and I kept saying that the CME that occurred on July 29th would arrive on July 2nd. So obviously that's insane. It's not going to take nearly a year for the CME to arrive. It's going to arrive on August 1st. So not only did I forget which month it is, I forgot how many days are in the month of July. August 1st is when that CME is expected to arrive. So here is the past 24 hours from SDO, and the story is still activity in this sunspot group right in here. That area is where that CME came from. Again, it is going to arrive on August 1st, not July 2nd. So let's take a little closer look here. And we do have another series of sunspots rising right up here in the northeast. So lots of solar activity here. As we ramp up toward solar maximum, we'll show you a lot more information on that. And if you enjoy the content, please visit the links below the video. If you haven't seen our homepage, smashomash.com, give Smash staff a raise by visiting our links. Smashomash.com is the official homepage of this channel. Thanks to everybody who has supported the content, and welcome to the Neo Renaissance. Some of the links you can find there include the Amazon shop. We got a comment yesterday on the shirt that I was wearing. Now today I'm actually wearing the Do Not Pole Vault the Caldera shirt from the Redbubble shop, and we've got new designs there as well. But check out the Amazon shop if you liked my shirt from yesterday. It is one of my favorite Hawaiian shirts that I've ever owned, actually. There it is, the King Kamea Hawaiian shirt, featuring the lovely colors of the ocean, pink irises and lovely pineapples on the Amazon shop. Again, you can find that right on the homepage. Right there is a link to the Amazon shop. We do have a storefront there. We've also got a Hemp Lucid shop, so another one of our paid promotions is Hemp Lucid. So check that out if you haven't. The featured products today are the mushroom products. So you can get those in both capsule form and gummy form. Perhaps try the stress stacks or the sleep stacks or the focus mushroom gummies or the stress mushroom gummies. Lots of different products available there. Again, you can see the link below this video. You can also see the links on our homepage at smashomash.com. Today's featured product from the Redbubble shop is the newest of our products. Again, today I'm wearing the Do Not Pole Vault the Caldera, which is our best seller. But today's featured product is the newest product in the shop, Smash News Network, least busted name in news. So it does feature the YouTube channel there. You can find that in many different products. Links both below the video and on our homepage to the Redbubble shop. So this one was based on a viewer request. Thanks to everybody who's been picking up merch. You're increasing the probability these videos will remain existent, publicly visible, and free for all to view. We've been trying to make this a sustainable operation for over 6 years now. And let's get back to space, because it's time to look at sunspots. So there's the current sunspot situation. Let's see, a little bit of growth here. A new sunspot just rose up here in the northeast. Besides that, those groups are largely stable. Again, most of the action is coming from this area right here, just south of where that filament it's the Nicki Minaj filament. It's on the way to Earth to arrive on August 1st, possibly causing a minor geomagnetic storm condition. So that is yesterday plus today in colorized magnetogram. And let's move on to look at volcanoes. It looks like a volcanic downtick in the past 24 hours. So here's the rundown of the currently erupting volcanoes. Bagana exploding, producing an 8,000-foot plume of volcanic ash on the Bougainville Island of Papua New Guinea. Semeru also producing a 14,000-foot ash plume there on East Java, Indonesia. Sangay in Ecuador exploding. Flight level 200. It's a 20,000-foot ash plume over Ecuador. And Sabancaya continuous ash emissions notes no volcanic ash plume size there noted. and Ubinas unable to detect if it is erupting. Please don't pole vault the caldera. Past 90 days of seismic activity shown here. We'll go over the past 24 hours, citing quakes of a 5 or greater magnitude. Here's the USGS list. We did have a number of 5+ magnitude quakes, like this 5.0 in Indonesia. That was at 11:19 Universal Time yesterday morning. Next on the list is, it's a long time with no 5+ magnitude quakes there. And then early this morning at 1:10 Universal Time, Central America saw a 5.6. And only 12 seconds later, Falkland Islands had a 5.1. So the opposite side of South America there. Almost simultaneous quakes. And then about an hour and 15 minutes later, Colombia had a 5.3. That was at 2:27 this morning Universal Time. And the most recent quake of a 5+ magnitude was a 5.2 at the South Sandwich Islands region. And that closes out the earthquake coverage. Let's take a look at some more imagery of the closest star here before we talk about space weather statistics. Here's the past 24 in SDO. That is 304 plus 171 angstroms. Here we've swapped out the 304 angstroms for 211 angstroms. Again, we have a lot of activity going on up here. Not only coronal hole activity, but also filamentary activity and the possibility of large solar flares. So the northeastern limb is a very likely spot to see a large solar flare in the coming 24 hours. And let's talk some more stats. So the 10.7 centimeter radial flux is now up to 179 solar flux units. 179 is the 10.7 centimeter radial flux. It is the emissions from hydrogen at the transition zone between the upper chromosphere and lower corona, right about where my mouse pointer is. And it is proportional to sunspot number. If you're new to the channel, congratulations on realizing it exists. Here is the 1-year graph from Solon.info. The black line depicts the radial flux, which is actually now up here now at 179 solar flux units. And the pink line is the 30-day sunspot number, 30-day sunspot number average, the Wolf number, and the red line is the sunspot number. Expect this to continue to rise here as we've got a number of large sunspots, especially around the northeast. Now, here's NOAA's forecast. NOAA agrees that the CME impact will arrive on August 1st. So there you have it, somewhere around like midday, and that sounds quite reasonable to me. CME to arrive August 1st, not July 2nd, as I said repeatedly on yesterday's video. Sorry about that. That is a thing that happens. So, yeah, forgot what month it was and how many days were in the month. So there's the NOAA forecast. I would agree with that. We could see as high as a KP 6.33. NOAA forecasting as high as a KP 5.33. It is dependent on magnetic field orientation and strength. So that's NOAA's forecast for the CME impact. NASA is forecasting it to miss. So here's NASA's Enlil spiral. You can see NASA expecting it to miss off there to the east. Earth represented here by this yellow circle. Also, you can see how close stereo A is to Earth at the moment, represented by the red square. Anyway, let's take a look at Earth's magnetic moment from space. Here are the past 4 hours of that. Magnetohydrodynamic pressure. It is geomagnetically calm at the moment. We do have what looks like a weak coronal hole high-speed stream, so we'll get to that here momentarily. That's the past 4 hours of Earth's magnetic moment from space. Here are the past 4 hours of Earth's magnetic moment from the ground. Likely to see some aurora there in places like northeast Canada. However, pretty minor because, again, it is a geomagnetically calm condition. You can expect a significant uptick. in 2 days. So there is the KP index, currently at 2. KP2 is the current situation for the planetary K index, an average of global geomagnetism. And here's a solar wind situation. We are seeing some variations happening right now. The BZ just went into negative territory and the magnetic field increased a little bit. So current conditions are BT of 6 nanotesla, BZ of -4, and then you've got a solar wind density of just over 5 protons per cubic centimeter. Solar wind speed here elevated at 520 kilometers per second. So this does have the signature of a weak coronal hole high-speed stream right here. This is definitely the sort of signature. Again, it is a weak coronal hole high-speed stream. The density only got barely above 10 there. And then as the density dropped, the velocity came up. So it looks like a weak coronal hole high-speed stream. We still do expect a significant signal on Tuesday, August 1st. There are your GOES magnetometer readings. The GOES 16 and GOES 18 have a geosynchronous near equatorial orbit. They orbit at about 23,500 miles of altitude. They are measuring the magnetic fields from inside of Earth's magnetosphere. And next we'll look at the heliospheric current sheet. It's super important, and there's some rapid variations happening in the heliospheric current sheet. Keep in mind, this is only a 2D image. It's just showing the polarity of the solar plasma. Keep in mind that this is quite a three-dimensional feature in the solar system. So this is only really concerned with the polarity of the plasma at the ecliptic portion of the solar system. So the part where the Earth orbits and that plasma undulates around and changes polarity. That's what you see happening here. So Earth is now in a North Pole current sheet. You can expect Earth to remain there for the next several days, barring some sudden change to the magnetic field structure, especially in that northeastern region. Keep in mind the magnetic field environment can change suddenly and with basically no warning. If you're getting warning, it's probably from our channel. Here is our line of sight field plot. Here you can see the sun's B field depicted in blue, north polar field in green, south polar field in red. Also the photosphere grayscale there. That's the gong magnetogram. And let's move to coronal holes. Yeah, coronal holes. So here's our coronal hole plot. We've got a bunch of North Pole-oriented coronal holes here on the Earth-facing portion of the solar disk. So there's the latest image. And here are coronal holes from SDO. Our fabulous 211 angstroms wavelength. And there are a lot of filaments here on the Earth-facing portion of the solar disk, obscuring a lot of those coronal holes. There's quite a bit of plasma there, despite those coronal holes. So some of those most of those not very well defined. Most of those of North Pole orientation. This one up here is South Pole, and there's one over here obscured behind even more plasma that is South Pole orientation. And that brings us to sunspots. So we've got some splentacular imagery for you here of sunspots. Let me just bring that up. And there you can see there is some possibility for significant flares showing up on the flare monitor here. Let's see, group number 7. So the flare monitor is showing this one has some significant magnetic shear. That's a beta gamma delta class sunspot group down there in the south. And many of these groups are magnetically complex. We'll show you the field structure of those before we get to our meteorology segment. So here's yesterday plus today. Let me speed that up a little bit. There is yesterday plus today from SDO Continuum. And let's show some more custom imagery. Here's a 24-hour video from SDO. So that's 1600 plus 1700 angstroms. These are good wavelengths to show sunspots. And we'll show some spectacular detail here in just a minute. There's the equatorial zoom. So here's this group likely to produce large flares here. It is beta gamma delta class. That's the southwestern limb. Here is the southeastern limb. These groups not quite as exciting as the ones in the northeastern limb. And there is the area where you can expect to see, in my opinion, the most likely place for large solar flares in the coming 24 hours. Next, we'll move to SEPs, and there still is a solar energetic particle event going on. There's the GOES proton flux, and you can see this having reached all the way up here to whatever that is, 147. That is particles per negative square centimeter. Yeah, the GOES proton flux here pushing back down toward warning levels. So it is causing continuing radio blackouts. The highest energy portion, the highest energy portion that moved up here, the greater than or equal to 50 mega electron volt proton flux, has dropped back down to baseline. The greater than 10 mega electron volt electron flux now dropping back down toward warning levels. But again, there is a continued polar radio blackout situation. You can expect that to go on until it gets back below those warning levels. So that's representing the D layer of the ionosphere, and those areas of attenuation. That is where the D layer is not refracting radio signals back down to Earth, but sending radio signals into space instead. So that radiation causes sort of an abnormal alignment of the material in the ionosphere. The polar blackouts are caused by the proton events, and the equatorial blackouts are caused by solar flares, the X-rays. So two very different phenomena there depicted by the deabsorption region's predictions. And the largest flare of the past 24 hours occurred right as I was getting out of bed at 8:20 Universal Time. It was an M1.87 class solar flare. And let's take a look at flares in 94 angstroms from SDO. So that is the past 24 hours. Here's the past 24 hours in SDO 131 angstroms. And let me just bring up the browse data feature here for a minute before we look at star charts. So if you've never seen this before, this is the browse data feature. We're going to put up just today's imagery. We're going to show that in 94 angstroms. It looks a little bit different from the SDO browse data site than it does if you make a HelioViewer movie. And we just want to see where that M-class flare came from. That most recent flare, that M2 did indeed come from down here. So there's the location of that one. And let's move on to a star chart, as I'm always interested in what's going on overhead, and we encourage our viewers to do the same. So here is the current situation over the Smash News weather station. The sun just coming over the horizon there. And here comes your solar system forecast. This is where heavenly bodies are today. There's where they'll be in 1 week on August 6th. Then let's move to coronal mass ejections. But first, the astronomy picture of the day, and it's pretty sweet. This is from the Icelandic Rift. A fantastic spiral-shaped aurora there, featuring green, pink, and purple aurora. apod.nasa.gov is where to obtain that if you want to check it out yourself. apod.nasa.gov, the astronomy picture of the day. Icelandic aurora there. So here come CMEs. And, yeah, CMEs. So, once again, this CME that occurred early yesterday, that's 108 frames from yesterday, July 29th. That one that occurred early in the morning, just right around, just after midnight on the 28th, frankly, that is the CME that will arrive on August 1st. We're not expecting a major geomagnetic storm. It could be as high as a KP 6.33, so it could be a G2 class geomagnetic storm. Not expecting super major fireworks, but there is certainly a CME on the way. And a fun fact, sometimes a CME is going to be a lot more extreme than it appears because it is spending a lot of time oriented directly at the Earth behind the coronagraph. So this one might be a little bit more of a direct hit than NOAA is forecasting. So just so you're aware of that, August 1st could see a geomagnetic storm starting sometime around midday. I would agree with NOAA's forecast on that. You can see it on the Space Weather Enthusiast dashboard if you want to go back and look. So that's 108 frames from yesterday. You can also see the solar energetic particle event striking the aperture here, all that static. Those are relativistic protons showing up quite quickly at a significant percentage of the speed of light. Here are an additional 17 frames from today, and that's not really very helpful at all. Here is Soho-Lasco C2 and C3, also not very helpful because we've got like 5 hours of missing data on those. But Stereo A saves the day, showing us the most recent data. So Stereo A is next. We're going to show that here on the left pane along with Soho-Lasco C3. And here's the most recent coronagraph imagery. Nothing really going on there. Just some minor outflow activity. So no additional CMEs headed this way. August 1st, expect geomagnetic storm conditions. Next, we've got the ground-based hydrogen alpha imagery. But before that, let's show our custom coronagraphs. Now again, keep in mind this is missing about 4 hours of data here at the end for the coronagraphs. So you're going to see the SDO continue to move there for a moment. That is, again, that's the missing data from the coronagraphs. And there could be a CME actually propagating right now from guess where? This active region right here. So right in here, there is some filamentary activity right now. So we'll keep you posted on that. If we have to make another video about that, we will do so. So there's another 24-hour video for you. And let's move to filaments. Filaments, they're exciting. And we name them after living people strategically because sometimes you name a filament the Nicki Minaj filament, and then we're going to have a Nicki Minaj solar storm. So join us on X, the quote social media and quote platform, which formerly was known as Twitter, now known as the brilliant branding of X. If you want to name filaments after living people, we do have some significant filaments here, like these down here in the south. And yeah, but at the moment, there could be a filament emerging from this area right here. So again, join us on X, the platform formerly known as Twitter, brilliantly rebranded. Oh, Elon, just such a great job there. You can also follow us on Instagram if you want to see things like diet, lifestyle, and fitness posts. You might even get recipes if you ask for them over at Instagram. Anyway, here are the past couple of hours. And it does look like there is a CME happening there. So that could be an earthly directed coronal mass ejection right here. We do see significant shimmering, some sparkly activity happening in here. That could be an indication that plasma is headed this way. We're not seeing it splash back down toward the chromosphere. So this is a process of both deductive and inductive reasoning, trying to figure out if a CME is headed this way, because we don't have the great angular view of stereo A. It's not at Lagrangian 0.5 anymore. It's practically right in line with Earth. So I do suspect there is some CME activity happening here. If it is earthly directed, we will let you know, and I suspect that it is, based on this short preliminary analysis. That brings us, by the way, to our bonus feature segment, where we're looking at satellite charging hazards, and they are currently minor. We've got surface charging here over Mexico and the Eastern Pacific as low-energy electrons build up, almost like static electricity on the outside of the spacecraft. Here is the GOES electron flux. This is measured at the F layer of the ionosphere using radiography from the high altitude orbits of the GOES 16 and GOES 18. We're in a normal operating range here, but we are seeing a coronal hole high-speed stream show up, so there is a little bit of a dip in the electron flux. Here's the one-year graph to put that in context. That's from solon.info/solar, and there is the forecast model. And NOAA is expecting a dip in the next 2 days, and I would agree with that. That looks like a legit model to me. I would expect both days to be lower and then lower for the electron flux. So coronal hole high-speed stream will drop it down. CME will drop it down even lower. And let's take a look at the layer where that is measured. The F layer of the ionosphere. Feel free to pause the video in this frame if you're not familiar with the altitudes of chemical concentrations, electromagnetic radiation penetration, atmospheric temperature inversion layers, solar minimum versus maximum thermosphere temperatures. Here is the F layer of the ionosphere, courtesy of Australian Government Bureau of Meteorology. It looks like we are seeing some anomalies here. If you're not recognizing them, don't worry. We'll show the anomalygram as well as the raw vibrational frequency, which is depicted here, megahertz, millions of vibrations per second. So here's the anomalygram, anomaly in megahertz from a 30-day median. It's shown daily on the channel as we show comprehensive space weather. And to quote Run DMC, we always tell the truth and then we never slip no lies in. Yeah, Run DMC. And let's bring up the latest image now that those have played through. There is 10:15 universal time ionogram and 10:15 universal time anomalygram. We'll also show the total electron content. It's the free electrons to about 12,500 miles of altitude. That's where your GPS satellite is located. And here's the total electron content forecast. The coupled thermosphere, ionosphere, plasmasphere electrodynamics model. And we are seeing some quite significant likelihood of major GPS errors, especially around the Southern Ocean, Antarctica, the Southern Indian Ocean, south of Africa, and a little bit in the South Atlantic, but mostly south of Africa, south of the Indian Ocean, and around the southern polar region. So those free electrons cause signal refraction. We've actually documented this. I did a bike ride with a 10,000 mile per hour average speed due to GPS errors. I don't think I was going that fast. I would have had a melted helmet. So here is the anomaly from the 10-day average over North America. That's the total electron content, the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. Free electrons out to about 12,500 miles of altitude, and no significant anomalies from the 10-day average happening there over North America. That brings us to the final portion of our daily space weather content. We're going to show the latest There's the latest intensitygram, and there's the latest colorized magnetogram. So at least one more sunspot group likely to get a name here in the coming day or so right there. It is a beta gamma class sunspot group. Let's see if we can get like 3 groups here in the same image. There we go. Make it 4 or 5. There we go. This group here is a new sunspot as well. So at least 2 new named sunspot groups up there in the northeast. Here's the full disk rockback. Multiple locations there where we could see a large solar flare. And let's move to meteorology, because we like to create value-added services here at the Smash News Network, least busted name in news. There are a lot of ridiculous piles of nonsense on the internet about not only just Earth weather, space weather, and so on. I'm not going to say the C word. You know, long-term temperature averages, the C word. Not going to say it. We're going on a wave hunt to start out our meteorology segment. This is the planet's largest waves. You might think they are in this typhoon that is south of Japan right now. 34 footers down there. However, that is not the world's largest waves. The world's largest waves are south of Africa. In the Southern Ocean down here, we've got 35 footers down there. So those are the stormiest seas in the world. If you're sailing, don't be in the Southern Ocean in the wintertime anyway. Besides that, things are quite calm. South of Australia, a bunch of big waves. So perhaps some good surf there on the Tasmanian coast if you're surfing in wintertime. So let's take a look at our regularly scheduled meteorological data here. The surface winds and jet streams. So there are the surface winds of the east. Again, this typhoon has moved back out into the western Pacific. Here are the jet streams of this side of the planet. Quite strong, doubled up, concentrated jet streams in the south. Quite incoherent jet streams in the northern hemisphere. Jet streams of the west looking like this, mostly staying north of the U.S. Anticyclone here over the southern Gulf, anticyclone here over New Mexico. Here are the surface wind conditions of this side of the planet. There is a strong low here off of Nova Scotia, which we will show you in a moment. Here is the surface wind scenario for the central world, and here are the jet streams of Europe, Africa, and the Middle East. The jet stream being the best single indicator of your weather forecast. If you had to pick one thing for global weather pattern forecasting, I would recommend the jet stream. Next, looking at mean sea level pressure. That's not pressure, that's wind. So there's pressure. Not a super strong low there, but it is quite windy in the western Atlantic. So there you go, off of Nova Scotia there. And there is the wind environment. Most of the winds there in the Southern Ocean, save for in the West Pacific. Quite a few significant low pressure cells there at wintertime for the South Pole. Next, clouds and fog over the Americas. That's our shortwave radiation map from the NASA GOES Interactive Weather Satellite Suite. Here's our weather.gov map. Weather.gov, visit the site if you've got warnings in your area. Hawaii's got coastal flood statements all around the southern islands, most of the islands there, coastal flood statements there at Hawaii, and heat warnings for the southern U.S. Next, we'll do some forecasts. And this one, I don't know why it's not animated. That is the weirdest. Never seen that before. For some reason, our temperature anomaly forecast is not animated. So let's show you how the sausage is made. So here is what we do with our forecast models. We're going to do the 2-meter temperature anomaly forecast here. We're going to show it for 72 hours on the GFS model. So here comes your 72-hour GFS temperature anomaly forecast. There you go. That's temperature anomaly in degrees Celsius for the next 3 days. Most anomalously hot temperatures there coming to Kansas, Oklahoma, Texas, and the Gulf Coast. Hot, hot, hot. Next, the jet stream forecast, the 250 millibar wind forecast. Jet stream is going to dip down here, way down to all the way down to Georgia. However, most of the jet stream here remains north of the U.S. That's a 72-hour GFS jet stream forecast. And last but not least, the 72-hour pressure and precipitation forecast. Next, your lightning mapper. This is where lightning has been striking for the past about 10 hours. Montana, the Dakotas, western Mexico, Tennessee, and the southeastern U.S. seeing a little bit of lightning there. And here's a current lightning map. Do we have any active cells? It looks like North Dakota has some minor thunder shower activity there. Somewhat strong storms there around the Fort Berthold Indian Reservation. So that is the lightning scenario there. Also some lightning around Phoenix. Lightningmaps.org is where we got it from. Check it out next time you hear thunder. Quite a bit of lightning here on the Atlantic coast. Maybe some good surf there for our Atlantic coast. And if you enjoy the content, don't forget to press like and subscribe. Now, we've got all kinds of ways to support the channel, but if you're unable or unwilling to do that, and open your cobweb-encrusted wallet to encourage us financially to continue to create these videos, press like, press subscribe, press share if you enjoy the most comprehensive daily space weather video in the known universe. It's right there. Keep these videos free and publicly visible for all to view by becoming a member of the Smash Team at smashomash.com/Smash Team. What's the incentive? The incentive is that you'll get additional content if you join at the gold or silver Smash Team level member. So check it out. smashomash.com/Smash Team is our subscription services site. There's also a bronze level. We do send out email alerts for things like space weather forecasts and so forth. So check it out if you haven't. And welcome to space. Congratulations on realizing that the channel exists. We're going to close out the video with U.S. Doppler radar, clouds and fog, and water vapor. Here's the full 50-state view. We're focusing on the lower 48 view. Here is clouds and fog, and here is water vapor. So that should clear things up. We've got dry air going all the way from Missouri to Nova Scotia. And here's a recap. U.S. Doppler radar depicting vertical motion in the air column. Those are ground-based systems, and a space-based system depicting 3.9 micrometer infrared radiation, and another space-based system depicting 6.19 micrometer infrared radiation, showing all the water vapor, not just clouds. Anyway, thanks for tuning into the Smash News Network, least busted name in news. Again, support the channel if you enjoy the content, as we would prefer to continue for it to exist. So, thanks again to Smash Team members especially, and I'm out. But while I'm gone, May that solar wind be at your back.